In this video, we're going to look at simplifying rational expressions. I am going to start with a rational expression made up of monomials. Now, a rational expression, notice the word rational has ratio in it, and ratio means a fraction. And so a rational expression is a fraction made up of polynomials. So I'm going to have, let's see, 7x cubed y to the fourth z over 28x squared z. Now, this is a monomial on the top. Even though we have x's and y's and z's in there, there's no plus or minus signs. And so this is considered to be one big term. And same thing on the bottom, no plus or minus signs, so this is one big term. So when we simplify a monomial over another monomial, we are allowed to simplify it piece by piece. We can look at the 7 and the 28 and say those are both divisible by 7, and we can divide those both by 7 and get 1 over 4. We can look at our x's and we can say we have 3 x's on the top and 2 on the bottom. And so if we take 2 of these off the bottom and 2 of these off the top, that's going to leave an x on top. Y's, we don't have any y's on the bottom to simplify that with. Z's, we have 1 on the top and 1 on the bottom. So z over z becomes just 1, or those go away or make 1. And so let's see what's left. On the top we have 1xy to the fourth, and on the bottom we have a 4. Now you don't have to put that 1 there, but you certainly can if you want to. You could have also used your exponent rules here to simplify for your x's, where we consider this to be division, so we would subtract our exponents. 3 minus 2 is 1, and for our z's, 1 minus 1 is none, which means z to the 0 power, which is just 1. Okay, let's do one more with monomials. 15c cubed divided by 3c to the fifth. All right, again, this is a monomial, this is a monomial. We can simplify it in pieces. The 3 and the 15 are both divisible by 3. So that would give me 5 over 1. I have 3 c's on the top. I have 5 c's on the bottom. That means I can cancel 3 c's off the top and 3 of these off the bottom, which would leave 2 left over. So I end up with 5 over c squared, or 1c squared. Now you could also use your exponent rules there, just like I said you could over here. 15 divided by 3 is 5. 3 minus 5 would be negative 2, and then you would have to fix that negative exponent by moving that to the bottom and making it c to the positive 2. So either way will work. Now, when you're simplifying rational expressions made up of monomials, you can do this, but that tends to lead to confusion when we get to rational expressions made up of binomials or trinomials or something with more than one term. Because a lot of people will look at a problem like this and they'll get excited. They'll say, oh, I see I can reduce my 3 and my 6, or I can reduce my 6 and my 12, and you cannot do that because this 3y plus 6 is a binomial. This is all one term, or one. You want to think of it as one thing. The only way you can cancel out a 3y plus 6 on the top is if you have a 3y plus 6 on the bottom. Just like the only way you can cancel out this 6y plus 12 on the bottom is if you have another 6y plus 12 on the top, which we don't. But what you can do is you can see if you can factor either of these polynomials. So on the top, I see that I can take out a greatest common factor of 3, which will leave me with y plus 2. On the bottom, I see I have a greatest common factor of 6, which will leave me with y plus 2. Now, do you see we have matching binomials on the top and bottom? Anything over itself equals 1. So this y plus 2 and y plus 2, we say they cancel. What that's really becoming is a 1. You don't have to write the 1 unless there's nothing else up here, then we will need that 1. But for now we can just say they cancel, as long as you understand that that means that becomes a 1. Now we're left with 3 over 6. 3 goes into 3 one time and into 6 two times. So that rational expression simplifies to 1/2. Let's try another one. X squared minus 1 over x plus 1. Okay, once again, this is a binomial and a binomial. You cannot cancel out these x's. You cannot cancel out these 1s. What you can do is you can try to factor. On the top, you should see that that is the difference of squares. And that will factor to x plus 1 times x minus 1 all over x plus 1. Now that you've done that, we have some matching binomials. X plus 1 over x plus 1 becomes 1. And we're left with just x minus 1. All right, now let's see. A squared plus 3a minus 10 over a squared plus a minus 6. All right, I'm going to say it over and over because I know that this is the mistake that most people make. This is a trinomial and a trinomial. You cannot start marking things off like these a squareds or these a's or trying to reduce this 10 and this 6. That is not allowed. So what you can do is you can factor, okay? So on top we have a trinomial with a leading coefficient of 1. We're looking for what multiplies to get negative 10 and adds to get positive 3. And that would be positive 5 and negative 2. On the bottom we have another trinomial with a leading coefficient of 1. We're looking for what multiplies to get negative 6 and adds to get positive 1. That's going to be positive 3 and negative 2. Now, if you are trying to figure out where I'm getting this or where I'm getting this up here, then that means that you need to review factoring, and you can go back. I have lots of videos on factoring that you can watch to review those concepts. All right, now that we've got this factored, we see we've got some matching binomials. A minus 2 over a minus 2, that'll become a 1. These are not the same. Do not try to cancel those a's out. Our answer is just going to be a plus 5 over a plus 3. You won't need the parentheses anymore. It won't matter if you put them, but you don't need them anymore. All right, the next one, 9x squared minus 4 over 6x plus 4. Okay, have I said it enough times? Don't start trying to cancel things, okay? Let's try to factor. So when we look at the top, my hope is that you see that that is the difference of squares. So I'm going to factor that as the difference of squares. The square root of 9x squared is 3x, so this will be 3x and 3x. The square root of 4 is 2, so that will be 2 and 2, and we'll put 1 plus and 1 minus. On the bottom, we have a greatest common factor of 2 that we can factor out, which will leave 3x plus 2. And then you see that we can cancel these, or they become a 1, and we are left with 3x minus 2 over 2. Can you touch those 2's? No, you cannot. This 2 is part of a binomial. Leave it alone. This is your final answer. All right. Now, this is going to be an example of what I mentioned earlier. I have said numerous times already that when you cancel these like terms here, that they become a 1. But you haven't seen me writing a 1 because we had other terms on top and other terms on bottom, and anything times 1 is just going to be what you started with. Now here, it will become important that you understand that when you cancel these like binomials that it becomes a 1. Because right here you see that there's nothing left on the top when I cancel that n minus 7 out. So it's vital that on this problem you put a 1 in its place, because we're going to end up with 1 over 9 times n plus 2. And if you just wrote 9 times n plus 2, you would be wrong. So we need a placeholder, something to hold this spot in the numerator, and that's going to be a 1 there. Okay, let's keep going. 3x squared minus 6x over 9xy plus 18x. All right, we know that we're not going to start trying to cancel anything. We are going to try to factor first. And so I look at the top and I look for a greatest common factor, and I see that they do have one. It is 3x, and I factor out a 3x, which leaves me with x minus 2. And on the bottom, I'm going to look for a greatest common factor, and they do have one. It is 9x, and that is going to leave me with y plus 2. All right, now these don't match, so don't try to cancel those or make them a 1. But now that we have these monomials out here, we can do some simplifying on them. So the 3 and the 9 will simplify to 1/3, and the x's will cancel and become a 1. And so on top, you don't have to put this 1. You can just put the x minus 2. 1 times x minus 2 is x minus 2. And then on the bottom we have 3 times y plus 2. Now there's never any need to multiply this back together. Don't do it here, don't do it here. Just leave it in factored form, and that would be your final answer there. Okay. On this one, we have y squared plus 6y plus 9 over 2y squared plus y minus 15. All right, a trinomial over a trinomial. Don't cancel anything. First, try to factor. All right, on the top, I'm looking for numbers that multiply to get 9 and add to get 6. That's going to be positive 3 and positive 3. On the bottom, I'm going to need to do my AC method. I'm going to come out here. If this does not look familiar to you, I have a video on the AC method. First thing you do is you multiply A and C together. Then you look for factors of negative 30 that add to get positive 6. Just kidding. Positive 1. I was thinking ahead. That would be positive 6 and negative 5. Then you group and take the greatest common factor out of each group. And you end up with y plus 3 times 2y minus 5. Again, if you don't understand that, then you need to go back and watch my video on the AC method of factoring. You have to use the AC method or another method. You can't just do it like this, because this has a 1 leading coefficient. When you don't have a leading coefficient of 1, you're going to have to use a different method. The method I use is called the AC method. All right, so now that we have that factored, we do have some like binomials that we can cancel. We can only take one of these y plus 3's off the top and one off the bottom. So our final answer is y plus 3 over 2y minus 5. Okay, we're going to do a few more. This is mostly a review of factoring. We have to be able to factor to simplify these rational expressions. All right, so here's another. We have a binomial on top and a binomial on the bottom. We always look for a greatest common factor first. I do have one on the top. It's a 5, so I can take out a 5. I do not have a greatest common factor on the bottom, but I do see that this is the difference of squares. Any variable to an even power is a perfect square, and we know 1 is a perfect square. So that is going to factor to y squared plus 1 and y squared minus 1. All right, so hopefully you see right here that these are the same. So those can simplify or cancel. They become a 1, and we're left with 5 over y squared minus 1. Now, I don't know if your teacher would require you to do this, but I see that this is the difference of squares and can be factored further. It doesn't help us to simplify the rational expression any more than what we already have, but it just breaks it down a little further. I would think that either of these answers would be acceptable on this problem. Okay, let's see. This one's got a lot of letters in it. AC minus AD plus 2BC minus 2BD all over 2AC plus AD plus 4BC plus 2BD. Wow. Okay, that's a beauty. We have 4 terms on the top. We have 4 terms on the bottom. Typically, when we have 4 terms, we're going to factor by grouping. But before we do that, we should check to see if we have a greatest common factor for the entire polynomial. If you look across the top, you want to see if these 4 have anything in common. I see like these 2 have an A and these 2 have a B, but I don't see anything that all 4 of them have. Same thing down here. I don't see anything that I can take out of all 4 of them. So I'm going to have to group them. And so I'll just use this. On my top polynomial, I'm going to group this group and this group. Out of my first group, I can take an A, greatest common factor, which will leave C minus D. Out of my second group, I can take a positive 2B, which will leave C minus D. And then I'm just going to keep going with that one. I have a like term of this binomial, C minus D, so I can factor that out, and that will leave A plus 2B. So this is the fully factored form of the numerator here. So now let's do the denominator. I'm going to look at these first 2 and these last 2 separately. So on the first 2, what do they have in common? It looks like they have an A in common, so I'm going to factor out an A. That's going to leave 2C plus D. On the second pair, I see that they have, let's see, a 2B in common, which is going to leave 2C plus D, which is good because I have this binomial that I can factor out, a 2C plus D, and it's going to leave me with A plus 2B, which is the fully factored form of the denominator. Now once I get there, I see I have these like binomials. I can cancel. They will become 1, the number 1. And then this is C minus D over 2C plus D. Please don't try to go any further. Don't try to cancel C's or D's here. This is a binomial and a binomial, so leave it alone. Okay, we are getting there, but we have some more to do. Next, I have 5x cubed plus 4x squared minus 45x minus 36 all over x squared minus 9. Okay, again, we're going to try to factor. On the top I see 4 terms, which makes me want to factor by grouping. I do need to check to make sure I don't have a GCF for all 4. I do not see one, so I'm going to go ahead and group. Out of my first group, I can take an x squared, which is going to leave me with 5x plus 4. Out of my second group, I know I want to take a negative number because this first one's negative. Looks like my GCF is 9, so I'm going to factor out a negative 9, which will leave me with 5x plus 4. And then that is going to be 5x plus 4 times x squared minus 9. Now I was going to go ahead and factor the bottom because that's the difference of squares, but now I see that there's really no need to do that because that and that match, so there's no need to do that extra work. I will just end up with the answer 5x plus 4. Okay, now, what if we have something like this? P plus 2 times P plus 3 to the 4th power over P plus 2 squared times P plus 3 squared. So, on this problem, P plus 2, like I told you, is a binomial. P plus 3 is a binomial, and I want you to kind of think of that as one thing. And so we have this P plus 2 to the 1st power. We have one of these on top. We have 2 of them on the bottom. Okay, here we have 4 P plus 3's on top, and we have 2 on the bottom. And so if we cancel all that we can, I know I can take one of these P plus 2's off the top and take one off the bottom, which will leave 1 on the bottom. For the P plus 3's, I can take 2 off the bottom and 2 of these off the top, which is going to leave 2 left on the top. I didn't need all this line right here. And that would be my final answer. Now, again, you can use exponent rules as well. This is a 1. You could say for my P plus 2's, I'm going to do 1 minus 2. That would be P plus 2 to the negative 1. For my P plus 3's, I'm going to do 4 minus 2 is 2. Then this one has a negative exponent, so we would have to move it to the bottom, and you would get this same answer. Okay. Now, let's look at this. X plus 2 over 2 plus x. Now, I know those are in different order. Are those the same? And if you're not sure, think about regular numbers because you're more familiar with regular numbers. So if I say 5 plus 2 over 2 plus 5, are those the same? Yes, 5 plus 2 is 7, 2 plus 5 is 7. So this would give us 1. 7 over 7 is 1. So in addition, the order doesn't matter. X plus 2 is the same as 2 plus x. So these will become 1. All right, but here's my next question. What about x minus 2 and 2 minus x? Are those the same? Well, again, let's use numbers to figure it out. Is 5 minus 2 over 2 minus 5? Are those the same? Well, 5 minus 2 is 3, and 2 minus 5 is negative 3. And 3 divided by negative 3 is negative 1. So no, these are not the same. This one gave you a positive 3. This one gave you a negative 3. So they're not the same, but they are opposites. And since they're opposites, when you divide opposites, you're going to get a negative 1. So when you see opposites in your rational expression on the top and the bottom, you can cancel them, but they're not going to become positive 1. They're going to become negative 1. Okay, So let's see how that might come to play in a problem. All right, what if I have 49 minus b squared over b squared minus 10b plus 21. All right, we're going back to the fact that we have got to factor before we can do any kind of canceling. And so I'm going to look at the top and hopefully I'm going to see that that's the difference of squares. And we have 49 minus b squared. So 49 is going to be 7 times 7 and b squared is going to be b times b. And it's going to be 1 plus and 1 minus. Y'all, you cannot just switch this around to make it b squared minus 49. That's not the same thing. You got to leave it in the order that it's in, and this is how it would factor. And then on the bottom, we're looking for what multiplies to get positive 21 and adds to get negative 10. And that's going to be negative 7 and negative 3. Now, we don't have any binomials that match exactly, but we do have 7 minus b and b minus 7, which are opposites. So we can cancel those, and my suggestion to you, you have to leave a negative 1 in the place of one of them, and I always leave it in the place of the one on top. Now don't put a negative 1 on both of them, because if you put a negative 1 on top and 1 on bottom, negative 1 over negative 1 is positive 1, and this has to come out to be negative 1. So just put 1 either up here or down here, and I'm suggesting in the numerator. All right, so what you end up with is you end up with negative 1 times 7 plus b on top over b minus 3. Now, another way that you might see this written is just putting the negative out front, like this. That would be acceptable as well. So anytime you are simplifying a rational expression and you come up with opposites on the top and the bottom, you can cancel them, but you have to leave a negative 1 in their place, because 7 minus b over b minus 7 is equal to negative 1, not positive 1.